Hi everyone, thanks for tuning into Notes of Design. In this episode, we have a very special guest joining with us. Let's welcome Amaresh Chakrabarti, a senior professor and current chair at Department of Design and Manufacturing at Indian Institute of Sciences, ISC Bangalore. He did his PhD from Cambridge, UK, where he led the design synthesis group of its Engineering Design Center, EDC, for 10 years before joining ISC as an associate professor. He published 35 books with over 300 peer-reviewed articles and has 13 patents under him. He also co-authored DRM, a methodology that is used widely as framework for design research. He also started the India's first design observatory and India's first indigenous smart factory. He is also the founding chair for International Conference Series of Research into Design, the ICOD. He had received the Career 360's Faculty Research Award in 2018 for being the most outstanding researcher in decision sciences and among the top global 2% of researchers in design practice and management. He received IISc's Alumni Award for Excellence in Research in Engineering in 2022. He is a fellow of the Design Society, an honorary fellow of Institution of Engineering Designers UK, and the current editor-in-chief of Artificial Intelligence for Engineering Design Analysis and Manufacturing journal published by CUP. This episode is packed with super awesome insights directly from Amaresh Chakrabarti, so do definitely tune in into the video. And also, if you want to experience the audio of this episode, we have it also on Spotify. With that, without further ado, let's begin this episode and let's welcome Amaresh Chakrabarti on Notes of Design. Hi everyone, thanks for tuning into this wonderful episode where we have Professor Amaresh Chakrabarti with us. Hi sir, welcome to Notes of Design podcast.
Well, thank you. Thank you for inviting me here.
So sir, if you could tell about your journey into design and how did you start, and what are your tips to the beginners in starting the design journey?
I think the two questions that you've asked, one is what is my journey and what would be my tips to budding designers? The answers are going to be quite different. So let me start with my journey. My journey was more accidental than well planned or designed. I started off. I grew up in a family where we had this unique combination of people. My father was a Sanskrit scholar, a literary person. My uncle was an engineer, and my aunt was an artist. And I grew in the middle of them, and therefore each was pulling me in their directions. So I had, without any planning, the great opportunity of getting an exposure to art and literature and engineering at the same time. So I loved all of them. And anyway, like children do, right? You give them 3 languages, they will learn 3 languages. And it grew up like that. And we were designing, pandals for various pujas and so on. And all of those things were happening without knowing explicitly what is it that we were doing. Right? We were doing design, but not knowingly. And then over a period of time, of course, one would choose a particular area, mostly professional. So I ended up being an engineer. So I joined an engineering college in Bengal called Bengal Engineering College, very old college, more than 150 years old, one of the oldest in the country, and studied mechanical engineering. And I did not like it. It's not true that I did not like mechanical engineering, but what I specifically did not like was what was taught as design. And the kind of design that was taught at that time, at least in my college, I don't think other colleges were that different from each other, was mostly saying, okay, if you have a gear, then, and there are so many, how many teeth should be there in the gear if its diameter is this much and so on. And pretty much all kinds of empirical formulas were there, and you just had to remember them and apply them. So there was not much excitement in doing that, and not surprisingly, this is something that he did not like. And over a period of time, when you are young and you know everything, right? When you're young, it's only when you get older you realize that you don't. So I knew everything at that time, and I decided I'm not going to study anymore. And it so happened that, in particular, I was absolutely hell bent that I'm not going to study design because I know how bad design is, right? So I graduated and looked for jobs because I wanted to stay away from academia. And I had, if you work hard, then you get jobs, right? So we had 6 jobs in various public sectors and private sectors and so on. And it so happened that at the same time, I also um, got a chance to study at both IIT Kharagpur in management and at IIS in, again, mechanical engineering. And well, of course, I would have none of it except the my friends were saying, well, management is something that is very hard to get to. Now that you have got it, you should study it, right? So after some thought, I decided to join that. It was also closer to home, right? I was from very close to Calcutta. I was from So I went off to Howrah station to take a train to join IIT Kharagpur, and it so happened that I missed the train. So I thought, well, if I miss the train, then I'm not going to be there before lunch, and if I don't go there before lunch, I don't get the scholarship for the day. So rather than taking and this would give me an opportunity to have one more day to myself at home. So I came back. And on the way back, I met a teacher of mine who was, in fact, my favorite teacher, Professor Pannalal Pal, a very well known heat thermodynamicist who studied under a very well known, very eminent professor called Professor Fichting in Germany, who was a student of Professor Prandtl. And we all know Prandtl from our basic engineering books, is that famous. So Professor Paul was one of the best teachers that I came across, and I absolutely loved the way he taught thermodynamics. So he said, "Well, you got that chance to study at IIS. So why are you not going? Or are you? I hope you are going." So I sort of was trying to say that no, I'm joining management, and he would have none of it. He just said, "No way. You must go to IISc, and not only should you go to IISc, you should go and study under." And he told the name of the person that I should go and do my project in, Professor Sondru Nagam, who was a fluid mechanicist there. So anyway, I then decided not to come back to IIT Kharagpur. Instead, I took a train to Bangalore and joined Bangalore IISc. And there it really transformed my outlook of both studying and also studying design. Now, before it did that, again, I was told by my professor that you should study fluid mechanics there and who you should study under. And this person was really incredible. Very tall and gentle man. He was the divisional chair at that time. And he was taking our fluid mechanics course at IISc. And it was mesmerizing. You just have to listen to it and think, wow, what is that? So I definitely wanted to do fluid mechanics, but it so happened that a friend, one of my 1 year senior, Abhijit Guha, who was studying heat transfer, he said, "No way, you should not study fluid mechanics. You should study heat transfer instead." And he, I think over a period of 6 months, convinced me why I should study heat transfer and not fluid mechanics. So I said, okay, I will study heat transfer. Because in IISc those days, our course was that in the first semester, master's course, first semester was common for everyone. You had to study everything. Because IISc said it doesn't matter, where you are coming from, because there will be maybe a lot of difference in where you came from. So your study may be quite different from each other. So they wanted to have a level playing field. They also wanted you to see what each subject is like if it's taught well, and then let you decide rather than coming with preconceived notions, right? Because at the end of the day, all subjects are interesting. It's just that we don't get to people who can present to you in a manner that is interesting, right? So anyway, so I decided to transfer now. From second semester would be specialized, and you can go to heat transfer, or you can go to fluid mechanics, or you can go to design, which is of course something I didn't want. So I said heat transfer. And then we had these three incredible professors in heat transfer. And just as we were planning to take our specialization, we realized that all three professors took sabbatical. So sabbatical is basically taking between 6 months to a year off and going to another place, another university usually, and then doing something totally different there. Okay, basically this is a way of them kind of rejuvenating and doing their own research and so on, and also collecting thoughts. That's very important for academics. Take a break and do something else. And it so happened all three professors went off. One went to Stanford, one went to Caltech, and one went to NASA. So we had almost absolutely nobody in heat transfer left. So now I had, of course, still the choice of doing fluid mechanics, which is something that I was planning to do. But then I had these two friends of mine, Aniruddha Mitro and Chatterjee, Sumit Chatterjee, and they both were my suppliers of notes from early morning classes, which I would often miss. And I said, why don't you guys join fluid mechanics? It's such a good course. They said, no way, we are going to join design. So I ended up joining design, not for a very respectable reason, for making sure that I get all the notes. But then once I joined that, so you can see that my journey ending up in design was totally accidental and not at all planned. But once I joined design, I started loving it, because this was very different design than what I knew from my undergraduate studies. These were solving open-ended problems and being creative, and I mean, lots of scope for bringing in your own twist to the tale, as it were. So that's my journey. And then, of course, it so happened that I was planning to apply for my PhD in various places, and ended up in Cambridge University, where I did my PhD, and I did that in design. And that was another level of experience where we had a ball of a time, and I ended up being a leading as the youngest lead in a center of excellence that was initiated by the Engineering, Science and Production Council, EPSARC of the UK, equivalent of DST in India, where they started a number of centers of excellence around the country to give a major push to research in design. And I was working on how to teach a computer to invent new ideas. And so this was the AI of the day. So it became fun. And of course, the rest is, as you know, I'm in academia, something that I thought I would never do, and so on. But now going back to your second question, which is that what would I give as tips to younger people saying to do design? First of all, I would tell them that there is not a single thing called design. Although we often use in India the word design to mean aesthetic design and design to take care of human factors, that's not a generic enough definition of design or focus of design. And there was a professor called Herbert Simon in Carnegie Mellon, who, in my opinion, gave the best definition of design. And let me tell you a little bit about Herbert Simon, because it's also inspiring. Professor Simon started his career as an economist, and he up until then, people would talk about rationality. Okay, they will apply a rational choice as a way of making decisions in economics. So people are fully rational, and they will make choices based on what is better in a very concrete, hard manner. But then Professor Simon came and he coined this concept called bounded rationality. He said that people are rational, but not all the way. Up to a point, they are rational. And then beyond that, they are not so rational. So the choice will be a combination of being rational and also not being rational. And And then he, through that lens of bounded rationality, he looked at the economic theories and said that the decision making will change in this manner if there was a certain level of irrationality involved in the decision making. In other words, his theories made economics a lot more realistic than it earlier was. And so for that, he got a Bank of Sweden prize of in Nobel Prize, which is also called Nobel Prize, right? In economics. And of course, he was a very good economist, but he was not interested in doing the same stuff all the time. So he decided, let me look at this area called management science and see what is there. So he moved from economics to management, and he started doing some incredible work, again, very fundamental, and changed the way management science was worked on. And then he got excited about artificial intelligence and computer science. So he said, okay, let me do a bit of computer science now. So he moved to computer science, and he was one of the early pioneers of artificial intelligence, along with Marvin Minsky at MIT, or Mitchell and so on, various others, Donald Michie in the UK. And he created, along with Alan Newell, one of his students, something called general problem solver. He said that, okay, a problem is generally has the structure, and I can use this kind of computer program to solve them. So you can throw at it a chemistry problem, and it will solve it to a certain level. You can also throw a very different problem, and it will solve it. So beautiful work. Obviously, artificial intelligence is a lot more complex than you can capture in a few lines of program. So obviously, we are still working in AI, and it also took on a very different shape than before. But he definitely was one of the pioneers. So now look at this guy. He worked in three very different areas, right? Economics, management, and computer science. And then it dawned on him that all the three areas in which he worked were kind of looking at these sciences of the artificial. These are not natural sciences, but they are sciences of things that are made by people. Economy is something that is made by people, knowingly or unknowingly. Computer programs are made by people, and so are management structures, right? How we manage resources. So he said, okay, so these are three different disciplines, but what is common across them? Is there a science of the artificial? And what is science of the artificial? It's design science, because we, by design, create things that are artificial, right? Artifacts. Artifacts are human constructions. So then he started thinking about it and gave a series of lectures, I believe, at MIT, on which then MIT Press asked him to write a book, and he did. And it's a tiny little book. You can just, and MIT Press has opened that up for everybody to read. So you can just go to internet, download that, and read it. And it was a phenomenal book. And what he wrote in that book is that design basically has two meanings. One is a design, okay, a design, and the other is to design, right? Now, a design may be a design of a power plant or a computer or a light bulb, and to design would be to design a light bulb, right? So in either meanings, there is an underlying understanding that you are doing design because there is something you don't like, right? Something you don't like, not necessarily because it doesn't work. Maybe it does work, but you think that it can work better. But sometimes it just doesn't work, so you want it to work. That is also there. Sometimes it is going in a direction that you don't like, the change of climate, for example, and you want to not make that happen. So in all of the cases, you start with something called undesirable situation. And then you dream up a situation that is more desirable. And then you plan for making that change to happen. So he said that designing, or a design, the first meaning, a noun, is a plan for changing something that is undesirable to something that is more desirable, okay? Or changing existing undesirable situations to preferred ones. And so it's a plan for change. And designing, or to design, is how you do that, how you create, how you figure out that there is a change that is needed and what change is needed. And second is how you figure out how to make that change to happen. So in other words, design involves both problem finding or opportunity finding or aspiration finding and problem solving, right? So that's what design is. So now if we take that, there is no reason why only aesthetic elements should be part of that change, or why it should be only ergonomic change, or why it should be only sustainable change. It's also functional change. It's also cost change, right? Resource change. It's also ability for people with certain, let's say, different abilities to be able to use it and so on. So you suddenly see that design is far more encompassing than that can be captured by saying only aesthetic and human factors are part of design. Okay, now, so my preferred way of describing design is X design. What is X design? I put something in front of the word design. That's what I'm doing. Somebody is doing engineering design, right? He is coming up with a way of constructing what is called a technical system, right? And somebody may be designing a logo, so it's a logo design. Someone may be designing a theory, so it's a theory design, and so on. You get the drift, right? It can be a curriculum design, it can be a policy design, and so on. So I would prefer to call it X design. So therefore, for the young stars that are looking for working design, the question that I would like to ask is, what kind of design, what kind of X are you going to do, or would you like to do? And look around. There are universities, there are colleges, there are schools who are teaching design of various X. What X excites? X is included in excitement also. So look for what X of excitement are you excited about, and accordingly choose your career. It's not necessarily true that all of you have to know how to sketch. For certain kinds of X, yes, sketching is very useful because quickly you can construct and see what your design is going to look like, and look is a very important part of it. Then it definitely is important. But maybe for other X's, it's the maths that is more important, because that's the way you can figure out how it is going to look, and not by sketching. So it very much depends on, but spatial thinking, okay, thinking about space. Just one second, I'll take some water. In general, for most designs, being able to think about the space is very important, because generally designs have a spatial description, and therefore spatial thinking is very important. But other than that, and that also, one has to figure out whether all designs require or not. But many designs do. But other than that, I think we really need to find out where we would like to work. And second is that then we need to find the right places at which to get the training for doing that.
So very beautifully you have, break down the word design and had given us great inspirations also while talking about it. So let's talk about what are some of the key areas of design research that you are currently focused on, and what challenges do you see in those areas, and also if you could explain us about the DRM methodology.
Sure. So I haven't spoken much about the research into design yet. So let me start by saying what is research, right? And again, it's a generic word and therefore has a generic meaning. So research is research in the sense that scientists understand. Okay, so I'll be using the word research and science interchangeably. Okay, it is not, when we studied, at least when I studied in my school, I was told that research is about systematic study of knowledge. Okay, the definition or the description left me not very satisfied. It can't be only systematic study of knowledge, right? There has to be something about the kind of knowledge that is produced.
Correct.
And possibly something about the way it is produced. I think both are important, but the description of the kind of knowledge that you would consider as knowledge that has come out of research or science have, in my view, four properties. The first thing is that at the time when it is coming out, it has to be novel. It has to do something that was not done before. It can be a little bit novel or very novel. That varies. Okay. Second is that it has to be purposeful. What is it that it is doing? Now, there are broadly two kinds of purposes. One is that we want to understand something, therefore, it improves our understanding. Right? We don't know how the cells work or how the planets move, and so on, and or how the traffic jams get created and so on, and then we work on that. Second is not just improving our understanding, but improving the phenomenon itself. How do I solve traffic jam? Right? How do I sense how fast the planets move and so on? So, as you can see, there is a, broadly speaking, there is an understanding kind of purpose, and there is an improvement kind of purpose. And mostly what scientists, natural scientists and so on, work on are the first kind. They say, okay, how does it work? How does quantum computing work? But sometimes everybody does also the second kind of work, saying, okay, how do I build a quantum computer? Okay, so both of them are there. So they, broadly speaking, there is a discovery kind of research and there is a invention kind of research. So what do you do if I want to understand design? So if you think of an area, let's say physics, what do physicists do? Physicists study the behavior of physical systems. They say, okay, how do physical systems behave? And of course, there is a application into it where they ask the question, how do I make a physical system behave better? Similarly, the chemists will say, how do chemical systems behave? Wherever there is a chemical system, for example, in our body, they will study that and say, okay, look at it. Let's see what are the chemical pathways by which hormones get created and so on. Similarly, the biologists say, how do biological systems behave? And so on. So, design researchers or design scientists or researchers into design look at design systems and ask the question, how do design systems behave? Now, what is a design system? One is, there are two meanings to it again. One is that these are systems that are designed, like Herbert Simon was talking about, an economy, a policy, and so on. Second is the systems that design those systems. In other words, designers. So, how do designers behave? Now, designers need not be humans. Increasingly, we see generative AI. Okay, so in fact, my PhD, I told you very briefly earlier, I was working on creating a machine that can invent. In fact, did invent and got a lot of prize on that. But point is not that. Point is that there is a system. Okay, you look at the birds, right? Some of the birds make their own nests. So it is not just us who invent. Even the other biological systems invent. So the question is, are there some generic behavior or specific behavior that certain design systems have? And that is the discovery kind of question. Second is the invention kind of question. How do you make or how do you help designers invent better? So we are into understanding inventing and improving inventing. Okay. Except that for a regular inventor, they will be inventing maybe a power plant or a IC engine or something like that, or a chip. We may help people invent the systems that invent. Right? So our call is a little bigger. So if you took that as design research, then there are multiple areas in which you can do design research. Design research is a relatively less known area of research. Physics has been around for several thousand years, for example, as a discipline. Mathematics has been around for perhaps longer. But design as a science and looking at it as a science, or just looking at the science behind design, okay, is something that has been around for not more than maybe 50 to 70 years. Right? So obviously we are a relatively young discipline, and to make matters more complicated, we are working on something that is incredibly complex. So again, without any disrespect to physicists who have done fantastic work, I am in love with physics. Still, the systems they are looking at are much simpler. They are looking at a system that is very well behaved. Every time you throw a piece of stone up, right? As long as you are not a Superman, it comes back, right? And it's very well behaved. Every time you throw a bird up, you don't know whether it is going to come back or is it going to go sideways or it's going to go at an angle. It has a mind of its own. It has to. So it is a combination of physics of the bird and this whole intent that is there in that system. So it is an intentional system. So systems that are non-intentional behave differently from systems that are intentional. Now, let's put a twist in that tale further. So obviously, what I tried to say was that biology would be more complex than physics. Okay, it would have to abide by physics, but it can utilize stuff that otherwise inanimate objects would do. Now, put more another layer of complexity. Let's say some of these biological systems are intending to solve problems for other biological systems by creating an inanimate system. That's what designers do, right?
Yes.
You see the complexity of that, and that's what you are trying to do research on. First of all, understand, and second, to improve. And that's what design research. So obviously, it's a young discipline, it's a far more complex problem, and therefore it will take longer for us to produce something that is what physicists take for granted after having done 2000 years of work. So that will take time. Having said that, there are some very interesting things that are coming out of this research. This research is now pretty well established in Europe and North America. And over the last 20 years, my colleagues and I we have been trying to make India also a major player in design research. And just to give an example, we recently concluded a conference called, many times, for those who don't know, there are research conferences, right? So what happens is that people who are doing research, they will be submitting papers that describes about what they have done. And this will be looked at by people who are knowledgeable in that area. And some of those get accepted by saying, yeah, that's new, that's interesting, and that is worth archiving, keeping for other people to read and build on. And these people will then gather together in one place and discuss about those together. And they will create their own communities, but also share that research so that can become the baseline now for new research to take off from that. And these are called research conferences. So in India, there is a conference called ICORD, International Conference on Research into Design, which I initiated in 2006 in IISc Bangalore. And it happens every 2 years. And now the 10th edition of that has taken place at IIT Hyderabad. And when I started this in 2006, we had 30 papers. Okay, mostly invited papers. I just came back from Cambridge, joined IISc, and I had a very strong network in Europe and North America. So I invited them saying, give us a paper. I'm running a conference. And then I found a number of people, key players in various IITs and so on in India who are doing design research and brought them together. Tiny little conference, 30 papers, 60 people conference. In January 2025 at IIT Hyderabad, we had close to 500 papers and we had close to 700 people. So obviously, this is a growing area of research in India as well now. And we are to be reckoned with as a force in this area. Now, what is its impact on let's say practice and education? Ultimately, that's what we would like to empower, right? We want to create knowledge that can be taught to people so that they can do design better and they can become better design teachers and design managers and so on. And this is where I would say that we have found ample evidence that systematic research into design produce knowledge that has gone on to develop methods and tools that have gone on to make people more innovative or create more innovative products and systems. So definitely it not only has an academic end, which is sometimes enough to do study. There was a long time we studied cosmology, not because we wanted to go to the end of the universe, but because he simply wanted to know. So this is curiosity-driven research. But then at some point in time, you suddenly see that some of that research becomes useful for going to moon, and suddenly there is a certain mineral in moon that is not found in Earth. So maybe it is useful. Or maybe one day we have to move out to other places, not moon, but beyond moon, in order to survive, because Earth may become inhabitable. So there are always a practical end, even to curiosity-driven research. But there is also problem-driven research or opportunity-driven research. And design can play a central role in both. Design research can play a central role in both. So there are lots of areas. You put the X and there is a corresponding research into X design. And there are multiple universities. I think IISc is very strong in research, particularly research into design process, design creativity, design informatics, sustainability, design for manufacturing, and human health, digital health, medical technologies, and so on. Similarly, IIT Bombay, IDC has very strong research groups in human-computer interaction, human factors, and several other areas, design education. IIT Delhi has also very strong research groups in many of these areas. So I think, these are, I don't need to say, because you can find those things more easily from Google than from me. Okay, your last question was about DRM, right? So see, just like you can do design and you can do design well or not, you can do research into design and you may be doing that well or not so well. Now, what do I mean by well or not so well? In research, just like doing design, excuse me, you may come up with designs that can be better, and therefore the scope for improvement in the outcome. You may come up with designs that are not bad, they're good, but it took much longer. It may have taken much more money and other resources to do it, and therefore it could take less to do that. So it can be either more effective, or it can be more efficient. Similarly, when you are doing research, same thing applies. You can do research more effectively and more efficiently. Sometimes, even if you are doing design well or design research well, you can still do it better. And so this is where, in the case of design methodology comes in. Okay, research into design methodology comes in, because they will develop tools with which you can make your designs better or make your designing better. Right? Now, as a researcher, the same thing applies. You can develop methods and tools with which you can make research more effective or more efficient. So, in this latter part is what I'm going to talk about now. So, just to recapitulate, we talked about design, what is design, and so on. We then talked about designers, how designers can be better or worse. And then third, we are talking now about design research, with which you produce knowledge with which to inform and improve the practice and education of design. And we are asking the question, how do we make design research better? Okay, so it's a long stick. Improve design research to improve designing, to improve designs. Okay, and in that sense, when we were doing our PhD, for example, I was working on computational creativity. How do I make computers creative for designing stuff? Because I came from a mechanical domain, I was interested in inventing mechanical devices, and I was asking the question, how can I teach a computer to invent mechanical devices? Just to give an example of research, right? So that when I talk about this boring research methodology, it makes some sense. So I was asking the question, sometimes what happens is that when you are designing something and you are used to designing that kind of things, your areas of focus become very, very narrow and limited. Even though you can do it very differently, you just do not pay attention to those very different ways. Partly it is to do with how quickly you want to do it and how efficiently. And of course, if you have all the knowledge in a particular area, you can do very quickly. And when you have to then think about a very different area, that is a lot more work. So we human beings always go to low energy states, low energy consumption states, right? Where that's how we probably have evolved, to consume less energy, because it's costly to put in more energy. But then, if you are going to invent something serious, you need to do that more cost there. So my question that the question that we are asking was that how do we get the designer out of their comfort zones and show them designs for a given problem that are quite different from what they're used to,
Correct.
and then help them, therefore, expand further, and then look at those designs as well and improve them, or just take an inspiration and move on. So how do we improve ideation? By using these designs as stimulus or stimuli, right? Stimulating ideation. So I was using automation in this case, because computers are developing these designs. I was using automation to empower humans, right? To see how do we make designers more creative by using automation. Okay, and I created this some method and tool and so on. Basically, that puts together a number of building blocks. Okay, some simple descriptions of basic mechanical systems that I can put in a database, and then I can ask the computer to put these together in different ways and come up with devices that are apparently different, but at the base level, they are a combination of those building blocks. Okay, if you think in a very loose sense, we are all different people, and so are dinosaurs and amoebas and so on, and even trees. But effectively, we all have this thing called chromosomes, and these chromosomes, fundamental of that is this DNA, right? And what is DNA after all? It is just a combination of 4 different amino acids, right? A, C, T, and G. So again, it's a building blocks combination, different combination producing very different animals or trees and so on. But applied to something more close to our home, in this case, mechanical devices. So we managed to do that. Now, the question is not how do you do that single piece of research. The question is how do you do any piece of research.
Correct.
And how do you teach somebody to do that in a more efficient and effective manner? So that's the question that we are after. So we went back, and this is when I kept saying we. So let me explain who these we were. So in 1991, as I was finishing my PhD in Cambridge, I had this. We had this engineering design center, a research center for excellence that I mentioned earlier, that was funded by the EPSARC of the UK. To do design research, in this case on engineering design, engineering systems design. It was initiated by a very well-known professor of design called Professor Ken Wallace. So what, along with several others, Professor Mike Ashby, a giant in materials research, and Professor David Newland, another giant in vibrations research, and my supervisor Tom Bly. So again, one of the greatest designers that I've ever come across. Incredible man. On one hand, he designed an underwater dredging device, which is still in use. On the other hand, he designed an underwater camera for taking photographs, and he invented a different configuration so that the photographs quality could become dramatically better. He designed yachts that won America Cup. He designed world's largest solar collectors in Malaysia. He designed solar what is this called? Windmill colonies, right? You see this large number of windmills next to each other. That's his idea. It started with US wind power back in the 80s when he was a consultant there and a professor at MIT. And he also designed a little device with a robot that can pick and place lots of different bacteria cultures in little test tubes and grow them together. Now, why should you do that? See, normally what a biologist does, and spends great deal of time on is that they will be creating cultures of different bacteria to see their behavior, and when they are matured their growth, then they take it out and use that for example, emulating a disease, and then putting some medicine to see how the bacteria reacts to that medicine and so on. So you need to grow uh, these bacterial cultures or microbial cultures very quickly and very systematically, but they take time. When a bacteria takes their own time to change. So what Tom did was said that this can be automated. I can have a cartridge of 200 by 200 sets of test tubes, like a camera. It does image processing to check all the time which of these are growing and maturing, and then at that point of time, it can be picked up by the, like a little, this earlier this gramophone record thing was there. We had this little thing that goes and comes back, something like that. And have a little robot like that. It just looks at that, picks up, puts a new one in, and so on. And by doing that, you can cut down dramatically the cost and time for creating those things. And biologists then gets more time to think rather than do this relatively mundane job, right? And he became a multimillionaire by selling that company very soon because it grew very fast and other people were interested. And then left the university, and ever since he has been designing stuff because that's his passion. So why am I saying suddenly Tom Bly? Because how does, if design was, or ability to design was confined to one particular domain of knowledge, then how can the same person design both an underwater camera and a yacht and one of those biology growing devices? So there must be something fundamental in design that cuts across domain boundaries. And in a sense, design research is trying to get to that. Okay, so that we can bring those designerly abilities and tools that can then be used by people to design not anything, but many things. But doing design research, as I mentioned to you, is rather difficult because you are trying to bring in human elements, technological elements, societal elements, business elements. They're very different beasts. Disciplines individually deal with those, right? You have management science deals with only organization. You have economics dealing with only the money part of it, resource part of it. You have software engineering or something like that, focusing only on how you apply a process. You have anthropology, archaeology, and sociology, and ergonomics, and so on, looking at various aspects of people, individual physical aspect to group of people, how they behave together. So, or mental aspects, psychology. So, how do you then design? How do you then do research into design? And so it's a complicated question. So we decided that we are going to focus on that. And this we is three people. Professor Ken Wallace, who was running that center, and Lucien Blessing, Professor Lucien Blessing, who at that time was a postdoc like me at the Engineering Design Center, came from Delft and Twente in Netherlands, and myself. So we all had our questions about what we find difficult in doing research into design. And so we pulled that together and came up with a methodology that fundamentally asks this question: if design research is to produce knowledge that is either to inform or improve practice and education of design so that products can be more successful, right? Then what are the research questions that we should ask? Now, the central element in this entire description is the word success. So, what is success is the first question. Now, success can be very different for different people. If you may be interested in sustainability of the villages. I may be interested in being able to make an object more easily. Another person may be interested in making a system more, more aesthetic, look better, and so on. So our goals may be very different. But whatever the goals are, there are goals. Okay, and there are certain things we are trying to attain by producing the knowledge that we do produce by doing research. So that's success. So his first question is, what is the success that you're after, or what are the criteria for success. Then the second question, of course, is if you are going to improve our chances of success, we need to first understand what is it that is influencing success at the moment and how well they are doing it. So that's the second question. Okay, how do you, what affects success and how? Okay. So it's like a observational study. It's like a discovery research, right? You're asking the question, how, what is affecting cost of a product, okay, what is affecting perception of beauty in a product, and so on. Then the next question is, okay, where are the gaps in that, and focusing on that, what can I improve? So third question is, what do I improve, what can be improved, and how can you improve the chances of success? And the fourth question is, does it actually get improved? Okay, it's no good saying, yeah, look, I created that, but then we have no proof or otherwise that it does indeed do so. So that's the fourth question. So, what is success? What influences success? How to improve the influences, and does it work? So, we put these four questions together and said that you must ask them in that order. And sometimes the research will only ask the first two questions, and then your steam is run, and therefore you have to stop. Or sometimes you ask three questions, sometimes all four questions, depending on the size of research. It may be an individual's research, it may be a group's research, and so on. And then, of course, more often than not, it doesn't quite work as you intended. So you go back and say, okay, how do I improve it further? Or you go further and say, maybe we should improve our understanding, or maybe our success criteria needs to be improved. So depending on how deep the revision has to be, you go back. So that's basically what DRM is. And in the beginning, we had no name for DRM, so we called it, because the word was design research methodology. So we started calling it short DRM, and over a period of time that stuck. So now it is called DRM. And I'm very happy, of course, to see that DRM has been used very extensively. There are more than 3,000 citations of DRM. So obviously, this particular research has benefited a lot of people, and not just in design research. It has been applied to psychology, philosophy research, and various other, of course, normal engineering research, and so on. Much more than we thought it would be used for, which is very heartening. And we wrote a book by Springer. Actually, Ken Wallace, while he initiated along with us this first work, was published in 1991, the first paper, and then in 1995, the second paper. But then Lucien and I, the two of us, we spent a great deal of time detailing out how to tackle those four questions. And it took us more than almost 15 years to do that. So finally, in 2009, we managed to publish the book, and which is pretty much, most of it is our own original work, and that is now what is used as the main reference for this work. Yeah, it is very satisfying that it has been used heavily. There are many courses that are offered on it, and so on. But it came out of exactly like what happens in design, that you are not happy with the existing situation. In this case, existing situation of how to carry out research, design research, and therefore you come up with a design. Hopefully, people found useful.
Thank you so much, sir, for contributing to the design community with such a great research paper, and this is a great inspiration as well. So, in your experience, what are some of the effective ways of designers for them to foster creativity and innovation in their work?
There are multiple ways. One major trap that anybody with knowledge can fall into. So this is more dangerous. This trap is more dangerous for people like me who have been in the area for a long time than those who are not. That knowledge, with every knowledge, every piece of knowledge, there comes also the context of that knowledge, where it applies. And we get stuck to this combination. We think this knowledge applies only to that context. And if we can decouple these two, then we are free to use this knowledge in other places and see if it works. If it does, great. If it doesn't, okay, we learned it. So then what happens is this concept, this idea in creativity research, it's called fixation. So fixation is about getting stuck to certain kinds of knowledge and their uses. So this will help you get out of fixation. Fixation is not good for creativity. So that's one thing. Second is, so would you stop then gathering knowledge? No. You should continue to gather knowledge, that every time you ask the question, is this the only place where it applies? Can I apply it elsewhere? So that is very important. We must continue to gather knowledge, because that's the baseline on which you are doing all of this. Without knowledge, there is no creativity. You can't create something out of nothing. There is, right? So that something has to be there. So something is a continuous journey. All of us are learning all the time. We need to keep our mind open. We need to look at other areas. So curiosity, therefore, is very important. Curiosity, okay, let me define that for you. Curiosity is when you are gathering knowledge for no reason.
Correct.
Okay, when you are non-purposefully gathering knowledge, that's when it is curious. How does it help? You pick up knowledge that, because they are not purpose linked, they are more free, and therefore you can apply them anywhere.
Wow.
Okay, so they are value-free knowledge. That is very useful. So observation is very important. All the time when you're walking, when you're looking at stuff, ask the question, okay, what is that? How does it work? Does it work well? What can work better? I think that's hugely useful. So I can go on forever because I work in creativity, but these are perhaps the three important ones. The fourth is, okay, maybe one more I'll add. Fourth is that it is quite useful to look at when you are looking at a design, look at what is it that it is doing very well, and what is it that it's doing not very well, and are they linked with one another? Is it that it is doing very well at the cost of doing very not well with something else? Let me give you an example. I want a large car, right? I want a large car because it's more comfortable, let's say, or I can pack more materials there. And I also want a small car because I can park it easily. Now, either I have a large car where I can pack in a lot of material and comfort, but I cannot park it well, or vice versa. So if you can resolve that conflict, as it's called, then you can come up with something really creative. For instance, can I have a small car that is comfortable? Can I have a small car where I can pack in a lot of things? Yes, I can. I can use the top, for example, and pack in a lot of things there. So this will help you come up with designs that are truly what some people call inventive. So that's another way of being creative. Find conflicts and resolve them.
Those are some really wonderful advices, sir. So let's talk about the impact of Industry 4.0. So how do you see the advent of Industry 4.0 impacting design processes, particularly in terms of sustainability and efficiency?
Okay, so let me explain what Industry 4.0 is. That various societies in the last 20 years or so tried to kind of analyze the past and see whether there are certain major stages through which the society has evolved, human society, of course. And the Germanic countries have come back with the concept of Industry 4.0. And basically what they say is that there are four major advances that have taken place in industrialization. The first was the introduction of machine labor, machines as labor or energy instead of humans or animals. And that happened in the time of the first industrial revolution, when James Watt improved the original engine of Charles Newcomen by making a design change to that improved its efficiency by a factor of 10. So it became 10 times more efficient, and therefore became much more affordable for mechanization. Then second one was when electricity was introduced as the kind of energy, and therefore you can move the energy from one place to another. If you are making a combustion in an IC engine, you have to utilize the energy there and then. Whereas if you turn them into electricity, you can then transfer it across, even store it in chemical form and utilize it later, like in a battery. So that gave much greater flexibility and also organization of labor. If people are put together like machines and they together like work like a system, then they can do a lot more than they can do in an individual haphazard distributed work. So those are the two concepts that were introduced in Industry 2.0. And then more lately, 1970s, computers came into factories and so on. And therefore, individual automation could take place. For example, I can make a machine work on its own. It is not only the energy part of it, which was done in 1.0, but also the computation part of it, right? Because this decision making could also be utilized along with the power that comes from some mechanical source. And therefore, we could have PLCs and SCADA and so on that could do the controlling of a machine. For example, I could sense and then take a decision of whether to correct in some manner and then do the correction by using some kind of actuator and control. So, but there were individual automations, one machine here, one machine there, or one activity here, one. What happened in Industry 4.0? They said, okay, why don't we connect all of them with each other? And just like people can talk to each other, can machines talk to each other? Can machines talk to people? Can people talk to machines? And can I gather data? And with that data and that connectivity, can I do distributed decision making across the entire system of an organization? And therefore, do stuff that would otherwise be very difficult or very long to do. And that's what Industry 4.0 is. It's a combination of 5 elements. One is data gathering, data collection, if you wish. Second is data connectivity. Okay. And third is data storage. And fourth is decision making or data analysis. In addition to introduction of a number of new technologies like virtual and extended reality or IoT and so on. Okay. Additive manufacturing and so on. So as a result of doing that, these functions will help you become more competitive. Now, your questions had multiple ends. One was, how does it influence design, first of all?
Yes.
So, let me simplify and say, broadly speaking, what Industry 4.0 is bringing in, or more lately, Industry 5.0, which is you need to humanize that, you need to make it more sustainable, and you need to make it more collaborative, where humans and machines can work together rather than one replacing the other. Essential message is the following: that how do I make a system smarter and connected? How do I make a system a connected, smart system? So then, in the context of design, we need to ask the same question: how do I make a product, a designed system, more smart and more connected? And by that, make it do stuff that it would otherwise do, but do it better, or do more than what it would otherwise do. Let me take an example. Let's say that I have sensitivity about sustainability, which everybody should have. I am traveling from, let's say, Thiruvananthapuram to Guwahati. Okay, so sort of southwest corner of the country to northeast corner of the country. It takes 3 days and nights to go by train, and a lot of people use train. Now, it's a family of 3 people, and each take at least 3 liters of water every day. That's 9 liters of water per person, 3 people, 27 liters of water. Give or take 30 liters of water, 30 plastic bottles. That's a lot of plastic waste. And they are strewn around the entire country. Now, what if I have a bottle like that? And oh, by the way, this actually reminds me. You see here, it says DCOE. So we actually at IIS initiated in my Department of Design and Manufacturing, we initiated a Center of Excellence in Design, which is funded by the government of Karnataka. And the mandate is that the next 4 years, we want to train 40,000 engineers in the basics of design. because most engineering colleges don't teach design. We we are going to teach 8 modules of design related materials: design, prototyping, business, and industry 4.0. So one module, each module is 1 week full time, 1 week each, hands on, and there these people are going to train in technologies of industry 4.0. That's one module. Design thinking and methodology, another module. Aesthetics and symbolics and semiotics, another module. Ergonomics, human factors, another module. Design prototyping. How do you do a quick prototyping to see whether your design works? Then mechanical prototype. How do you do a detailed mechanical prototyping and see how it works? Both virtual and physical. How do you do an electronic prototyping? Similarly, virtual and physical. And finally, a business modeling and entrepreneurship model. So 8 weeks of training, and we hope that this gives you a design layer and an entrepreneurship layer that you can add to your already known technical knowledge and therefore invent better. And that's something that we have already initiated. And in the next 4 years, starting in June, we will be offering those courses. So just a quick suddenly remind. So anyway, but going back to the bottle and not the logo. If I have a metal bottle, then I save plastic, and this metal will stay for a long time. So I use, so that way I save more plastic, or save ourselves from plastic. And but the problem is that where am I going to get the water from? The reason why we buy a bottled water is because we don't trust the water that we drink, even though most railway stations have pretty good drinking water. I mean, if you were maybe 500, 600 years ago, you would take that water any day because that's much better than the pond water or the canal water that you would be drinking directly from. But today we are, of course, more sensitive. Fine. So here is, so what should happen is I should carry just a bottle and then go into the railway station, fill it out and come back to the train, right? The problem is that of trust. So let's say that I have added some sensors there, so you can tell me whether this water is drinkable or not. And I can put some filters that you can do that and then tell whether the water is drinkable. Okay. So that part is more like industry 3.0. Okay. So I have created industry 3.0 bottle. How do I make it industry 4.0? Okay, let's put an IoT on this one and I connect it to the internet. Okay. And it can tell me that yes, the water looks okay based on my analysis of the sensors. But remember, I don't have all the sensors. And I am seeing in the internet that this area has this particular disease, for example, thalassemia. And therefore, I don't have a thalassemia sensor here. So I suggest that you don't take the water from this water, wait for another 20 minutes, and then you can take the, because since you are going to Guwahati, 3 stations down the line, there is no thalassemia case, you can take the water from there. So now we have made it industry 4.0. You are utilizing not only data collection and storage and analysis, but also data connectivity from beyond this machine. So that's the kind of impact it can have. It can have smart products and systems. And your last question was, would it impact sustainability? Well, like most technologies, the question is double-edged. On one hand, it will improve sustainability because you are utilizing, for instance, less plastic, right? On the other hand, you are also producing new sensors, and therefore digging metals and so on, rare earths from somewhere, utilizing this, and then later on to dismantle will be problematic and so on. And all the energy that you require in order to calculate, right? We are running huge, big power plants in data banks that we call cloud. So I think it's a question which requires a systemic answer. We need to put both of these together and say, okay, overall, are we winning? And two, how do we, even if we are winning, how can we make the bad things go down and the good things go up? So I think the question is open right now. And it requires a lot more research to answer it.
Thank you so much, sir, for sharing all these wonderful insights. So looking ahead, what do you see as the future trends in design, and what advice would you give to aspiring designers, and what's your take on AI influencing design?
I think you have already nailed the first question and the last question together. That one of the major trends in design is going to be how AI impacts it. And AI has become very, very uh, present in our lives already. Many times we don't realize how present it is in our lives. When you see a chatbot talking to you, it's not a human being; it's a robot, and that's actually a AI program. That's a very simple example. Many times you will see that you do some search and afterwards somebody is sending you materials in that space. You go to Netflix, watch one movie, and you see that your that kind of movies are being shown more to you. All of these are effectively a kind of industry 4.0 AI combination that you are seeing. You are being watched, and that data is getting analyzed, and accordingly, various offerings are being tailor made to you. So this is going to happen more and more. Recently, I taught this design thinking and methodology course to the trainers that are going to offer that program to 40,000 engineers. And I introduced AI in every step of the design thinking process. How to identify opportunities, how to come up with ideas, how to analyze and evaluate those ideas, and how to select the best idea among them. Uh, these large language models, for instance, can apply to all of them, but you have to train them properly. Otherwise, they will give all kinds of spurious results, and that's something one has to be careful about. But I'm sure with time, even that will become less. It will learn how to become better at doing that. So there is a huge potential for utilizing that and making our work better. Uh, I think again, any technology will have both direct and indirect impacts. Whenever new technology comes, certain jobs become less available. Same thing is going to happen here, and certain other jobs are going to emerge. The same thing is going to happen here. Um, for those designers who can utilize AI better as a tool, will thrive. For those who don't, they will not survive. So I think it's going to be a combination of those. It's important that we keep a very close watch on what AI is doing, how it is progressing, and keep asking this question: how to utilize that for making us better.
Thank you so much, sir, for sharing all these wonderful insights with us. So, could you please share us how does your day look like, and also some book recommendation to our viewers out there?
Right. So the day for an academic, I think the days look like I'm on holiday all the time, and it looks like I'm not on holiday ever. So in other words, I, for example, stay inside the IISc campus, which means my department is about 15-20 minute walk from here. So if there is at 10 o'clock at night, there is a problem in the department, they will call me and I'll drive down there, which will take 5 minutes. This morning I got up and I walked for a while on my research. So these are 24/7 kind of. Even in the middle of night, sometimes I'll get up and write things down because something interesting came out. Um, so I would say that an academic's life uh, is filled with excitement and something not so exciting. Uh, but the most important part is that there is no there is no respite. There is no time when I'm not doing something. So that's one. And when it comes to the recommendation of books, I will mention maybe two or three. The first one is I've already mentioned it. It's The Sciences of the Artificial by Herbert Simon. It's definitely worth reading. Uh, Second one, if you are interested in engineering design, then there's a book by Gerhard Pahl and Wolfgang Beitz called Systematic Design, Engineering Design: A Systematic Approach. It's worth reading. If you're into product design, a book by Carl Ulrich and Steve Eppinger, both good friends, and student of Tom Lai, my PhD supervisor, both from MIT. Is worth reading. Very good book called Product Design something. Um, if you are into other kinds of design, then there will be very good books in those areas. that experts in those can speak about. The third book that I would humbly add is, of course, DRM, the research methodology book that we wrote, because it has been incredibly helpful, especially for researchers in this area. Those would be my recommendations. And maybe before I finish, maybe there is a minute left. I will just talk about 2 or 3 individuals that have played a very significant role in my journey as a design researcher and in my understanding of design. One, of course, I have already spoken about is Tom Lai. Tom Lai was my PhD supervisor. Came from South Africa, did his undergraduate in mechanical engineering, and then decided to do his PhD in physics. And did physics on shock waves and how to cut rocks using shock waves. Okay? And granite could be cut with very high precision using his shockwave generator. You can't vibrate the rock very much. It doesn't like being vibrated. So basically, by vibrating in a very small zone, you can just, split it open there. That's the idea. And then I told you about all the yachts and other things that he has designed. So he's a born designer, I would say, and very different. He designed the civil engineering building of University of Minnesota. Can you imagine? And also went on to MIT and designed the largest solar collector. So wonderful to see somebody so wide in his ability to design, and giving me the faith that design as a research area therefore makes sense. That there is something beyond domains as design. So that is one. Ken Wallace was a remarkable individual, the professor who started the EDC at Cambridge, because he transformed the design teaching at Cambridge University's engineering department. And most important thing that I learned from him was his ability, even as a very high senior level professor, he would say, go and practice, because that's the only way we can make it better. I'll probably stop there. My parents, I told you about my uncle and my aunt and my father, all gave me important insights into different kinds of design, literary design, engineering design, artistic design. So again, those are important.
Thank you so much, sir, for sharing all these wonderful insights with us. We are looking forward to host you again in our upcoming sessions. Thank you so much, sir.
Thank you. Take care. Bye now.